welcome back to Algo Explain. Today we're going to be going over the greedy algorithm and its everyday uses in CS as well as real life. So what exactly is the greedy algorithm? The greedy algorithm is an algorithm that makes the most optimal choice at each step of the way in an attempt to solve the whole problem. Right now that makes no sense, but later we're going to do a problem and hopefully you'll understand the situation better. So what exactly is our problem? Our problem is, what is our problem, like the algorithm used to solve the problem? You get it, right? So our problem is a cashier wants to give back to a customer his change, but he wants to give back the change in the least amount of coins possible, right? Yeah, if let's say there's 25 cents, he doesn't want to give back 25 pennies. He wants to be most efficient, right? Henceforth, the efficient algorithm, as I like to call it, but other people like to call it the greedy algorithm, right? So we need to code an algorithm that will give back the most efficient coins. Okay, so let's explain this problem a little better. So um, let's say we have 32 cents. A greedy cashier, or I don't even like the word greedy, honestly, an efficient cashier would give back the coins in the least amount of coins possible. So is 25 greater than 32? No. So if we do a 32 minus 25, we won't be losing coins. But let's say, okay, I don't know if this exists, but let's say there's a 50-cent coin. If we did 32 cents, is 50 greater than 32? Of course it is, right? If we did a 50 minus 32, it would be negative 18. We're losing coins here, right? We don't want to do that. We want to do it so that we have a positive amount of coins. So is 25 less than 32? Yes. So we want to now subtract 25 from 32, giving us 7. So now, are we going to use another quarter? No, because then we're going to lose money. We're going to lose exactly like 18 cents, right? Which store owners can't handle. 18 cents is a lot of money. So now that we have 7 cents because we did the 25 minus 32, our next coin that we can do is 10 cents. But is 10 greater than 7? Yes. So if we did the dime, then we'd have a negative 3 cents. We'd be losing money again. But 5 cents. Is 7 greater than 5? 7 is greater than 5. So if we did 7 minus 5, we'd have 2 coins. Or 2 cents. 2 cents is now less than 5 cents. So we can't use 5 anymore. Now we need to use 1. So 2 minus 1, 1. 1 minus 1, 0. So in total, we had to use 4 coins to get from 32 to 0 cents owed, right? That's the most efficient way you can do it, assuming that the coins are only 25, 10, and 15. 10, no, sorry, 25, 10, 5, and 1, right? So let's see the math here, right? Because words aren't the best way to show mathematical things. So, okay, so the math form here. So let's say we have 42 cents. First, we want to do, um, first we want to see if 42 is greater than 25. 42 is greater than or equal to 25. It says yes here, and of course it's true. 42 minus 25 equals to 17, right? Is 17 greater than or equal to 25? No, so we can't use a quarter anymore, right? Is 17 greater than or equal to 10? Yes, 17 is greater than a 10. So 17 minus 10 will give us 7. Now we're going to go back to the dime before and see if we can use the same dime. Can we? Is 7 cents greater than or equal to 10 cents? The answer to that is no, of course, because 10 is not less than 7. But is 7 cents greater than 5? Yes, it is. So what we can do now is 7 minus 5 equals to 2. Now that we have 2 cents, we have to determine whether 2 is greater than 5. Of course, 2 is not greater than 5. Henceforth, we have to go to 1. Is 1 penny, so is 2 cents greater than 1? Of course it is. So 2 minus 1 equals to 1, and then we do the same thing until our value equals to 0. Here, it shows that we're going from 42 cents to 0 cents. But in our program, we need to see how many coins that are necessary, right? How many coins are necessary in order for us to go from 42 to 0? Right now, this math isn't helpful. Well, obviously, you can alter a literal and just keep adding coins as soon as we like minus 1, right? But we should leave that to the computer. So how should we code this? So we should first start off with 2 variables. One should be cents owed and one should be coins, right? Coins given. Now we must take the values of each coin. No, sorry. Now we must take the value of the coins and deem the biggest bite that we can take without losing money. So again, we're going back to we can't have negative money because the store owners are going to get angry at us. So back to 42 cents, right? 25 cents is less than 42. That's why we were able to take it, right? But then, so we have to keep on doing this, right? With each coin and be like, 42 greater than 25? And if it is, then subtract them. If when you subtract them, see if the remainder is greater than 25. If it is, then keep on doing this, right? So automatically you'll think, oh, that's a while loop. Uh, so, but then 42 minus 25 is 17. And you're like, oh, 17 is not greater than 25. What must we do? We have to go down. We have to go to the next value. It's 10 cents, right? So now we do 17 minus 10, 7. Keep going down and down and down. And so keep going down and down and down and down, right? It's a while loop, right? We have to just like say while our cents are greater than 25, subtract them, and then just keep going down and going down and down and down, right? But while we do this, each time we iterate through the loop, we need to add 1 to our coins. So let's code it now. Okay. So let's start off with values. Let's start off with cents owed. So cents owed is going to equal to, oh, it's going to equal to an input, right? Shoot. Int input, and then yeah. So cents is going to be equal to an input, right? And then so we can code it so that it's like, oh, if it's not greater than 0, then it has to keep looping, then it has to keep going back. But like that's not really involved. Like that's just extra steps. If you want to take that, then I can post another video on how to keep iterating an if loop if it's not true, right? Now, as stated in our notes, our next variable should be coins given, which right now should be 0 because obviously you have not given any coins yet. So remember how I said we have to keep using while loops until it's greater than, right? So our first value is 25 cents, or our first value is 25 cents, or our first quarter is 25 cents. While our cents owed is greater than 25, we must keep on doing this. Oh, what the hell happened there? While cents owed is greater than 25, we must keep on going. Okay. While cents owed is greater than 25, we must take cents owed and we must subtract it by 25. This will equal to cents owed. So now we are updating our variables. Remember how in last video we learned how to update our variables? So that's going to come in handy here. But also, we're forgetting a step. If we just keep on going here, let's say, okay, while cents owed is greater than 10. We're forgetting something because our coins need to be updated. Our coins need to have 1 value added to them. So now that 1 value is added to them, I don't know what's going on. Oh, coins given. Okay, coins given. So while our cents owed is less than 10, we want to do the same thing over and over and again, right? Until we get to the penny. So let's just copy and paste this. And again, I don't recommend copy and pasting this. Copy and pasting because so many things can go wrong with the values and all that. So first it's our 25 cents, right? We're subtracting 25, and then we go down to the 10 cents. We go to the pennies because that is the next available one. So now we want to take our cents owed and we want to subtract that by 10, but we still want to keep adding a coin. And then over here, we want to give it 5, and then over here, we're going to give it 1, and we have to change these values so that it's 5 and 1. So right now, you may not see it, but there is a big error here. An error that's going to just lead to us, lead to improper calculations. And that error is, so let's iterate through our loop manually, okay? So let's say our coins owed is 25. So our cents owed, is cents owed greater than 25? 25 is not greater than 25, so it's automatically going to go to 10. 25 is greater than 10, so now it's going to do that. So this is an improper calculation. What it should have done is 25 minus 25, because 25 should be equal to, greater than or equal to. That's very important, or else it will lead to improper calculations. So now it's greater than or equal to. So are we done? No, because obviously we're not printing any graphics, right? We're not printing any coins equals to. So coins equals to coins given, and then print our change, of course. Change to. So the best thing about writing these algorithms is seeing the values change as the computer computates them, right? So what would change be? It would be cents owed. So now we just copy and paste this for every one of them so that we can see our values change. Oh, I don't know where that happened. And then just keep on going. So now if we run the program, it's going to ask for an input. Let's put 42 because we checked it over here, right? I think it takes like 4 coins or something. So it says that we need 5 coins in order for this to be true. Is it doing the math correctly? Let's see. So our first math should be 42 minus 25. It doesn't here, 17, right? It adds 1 coin after that happens, and then 2 coins, 3 coins, 4 coins, 5 coins, 6 coins. And that is how you use an greedy algorithm to solve the problem stated here. Well, thanks for watching, and subscribe if you liked, comment if you enjoyed, and have a nice day.